Okay, this is the partial fractions formal homework. So we'll take a look and see how we get on with these questions. Definitely a few tough ones there, but let's see how we get on. So first of all, we need to factorize the bottom line here. It's a nice straightforward one. I hope we're okay with that. So I could rewrite that then as x plus 7 all over x plus 2 upon x plus 3. And my partial fractions are two linear ones, so it's a over x plus 2 plus b over x plus 3. Finding my common denominator, it's going to be a upon x plus 3 multiplied by x plus 2, x plus 3. And multiply top and bottom of this one by x plus 2, so it's b upon x plus 2, x plus 2, x plus 3. And next line then I can just join those two things together under the same denominator, meaning then that this line x plus 7 should be the same then as the numerator up here. So my next line now is going to be x plus 7 equals a upon x plus 3 plus b upon x plus 2. If I let x equal to minus 2, sorry, I've written the wrong question. Brilliant. So this is a 2x up here. No, it's not. Sorry, I was right. I get, sorry, just lost my mind there for a split second. Minus 2 plus 7 is 5. I jumped on to the next question. Because that's minus 2, this disappears, and that's then just going to give me a, so my a is a 5. If I let x equal minus 3, minus 3, I'm going to get 4. Minus 3 means this disappears, minus 3 here is minus b, and that gives me a value then where b equals minus 4. So that's my final line then. My question was x plus 7 all over x squared plus 5x plus 6, and splitting that into its partial fractions, I get 5 over x plus 2, take away 4 over x plus 3, and note that we tend to take the minus from here and put it here. It just looks a little bit tighter. Question 2 then. 2x minus 7 over x minus 5 squared. This is our second type here. And hopefully you spot that this is a repeated factor. So I set my partial fractions out as a over x minus 5 plus b over x minus 5 all squared. I need to make the denominator here the same as the denominator here, so I'm just going to times top and bottom of this one by x plus 5. So it's a upon x minus 5. I said the wrong thing there, but that's okay. X minus 5 all squared plus b x minus 5 all squared, and that's equal to this here. My top line then, I'm just going to join those two together, same as the previous example, and I'm going to get then 2x minus 7 equals a upon x minus 5 plus b. If I let x equal to 5, 2 times 5 is 10, take away 7 is going to give me 3. The a part disappears and I'm just left with the 3. To work out a, just let x equal anything you want really. The easiest thing is to let x equal 0. That would give me then a minus 7 here equals minus 5a, and my b then here is a plus 3. Take that over the other side, divide by minus 5, and we get a value then of a equals 2. So we are pretty much there. My question was 2x minus 7 all over x minus 5 squared, and splitting that into its partial fractions, I get 2 over x minus 5 plus 3 over x minus 5 all squared. Question 3, starting to get a bit more complicated, but still should be okay. We're going to have 3 factors here, one of which then is a repeated factor. So I'm going to write a over x minus 2 plus b over x minus 1 plus c all over x minus 1 all squared. People struggle here a wee bit with the common denominator, but hopefully we'll be okay here. So what do I need to do? I need to make the denominator of each of these three things the same as the denominator here. Here I have an x minus 2, so I need to multiply top and bottom of this one by x minus 1 all squared. All over x minus 2, x minus 1 all squared. Plus b. Need to multiply this one by one of the x minus 1s and then an x minus 2. Again, to give the same denominator. Denominator has to be the same. And the c, how to make the denominator the same as this, I need to multiply top and bottom then by x minus 2. So c upon x minus 2 all over x minus 2 x minus 1 all squared. So far so good. I can join that all under the one denominator. That will mean this equals this, which equals my next line. So I can then make the two numerators equal to each other. So that means minus 3x squared plus 10x plus 5 equals a upon x minus 1 all squared plus b x minus 2 x minus 1 plus c upon x minus 2. If I let, I'm really sorry, that question's wrong, isn't it? Right, okay, let's go. That's a plus there, 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 that's a plus there. It's just in my notes it looks very like that's a minus, so it's an x plus 2. Hopefully that's okay. If I let x equal to minus 2, if I let x equal to minus 2 and sub it in there, you can maybe take my word. Well, minus 2 squared is going to give me 4 times 3 gives me then a kind of minus 12, minus 20, then plus 5, so minus 27. Why am I doing that? Means this b bar is going to disappear and the c part is going to disappear, so minus 3 then squared is going to give me 9a. That gives me a value of a then of minus 3. If I let x equal to 1, if I let x equal to 1, I'm going to get 12 here on this side. This is going to disappear, this is going to disappear, and I'm going to get 3c. That gives me c then is 4. If I let x equal to 0, lots of it's going to disappear, and I'm going to get 5 equals, if x is 0, minus 1 squared is just 1, so I just get an a. If x is 0 here, I get a 2 times a minus 1, so I get a minus 2b. And if x is 0 here, I get a 2c. If I sub in minus 3 for a and 4 for c, giving me then an 8 there, and rearrange, weirdly I get 2b equals 0, which means that b is equal to 0. That means that this term doesn't exist up here, so there is going to be no x minus 1 term. So my final line then, I can just about fit it in. Minus 3x squared plus 10x plus 5 all over x plus 2 upon x minus 1 all squared equals a. What's my a? Minus 3. We'll go for the minus 3 up here. I don't like it sitting out the front. Just contradicting myself, but that's okay. No b term. And then my c is 4 plus 4 all over x minus 1 all squared. Alright, you can just about see that, but we're all good. Okay, question 4, and to be honest, I should have been saying this for questions 1, 2, and 3. The first thing you always do whenever you do partial fractions is to check that the degree of the numerator is smaller than the degree of the denominator. So we have a quadratic up here, and we have a quadratic down here, so we need to divide through first of all. You can't do these partial fractions unless you have divided through first of all. So we're going to divide through. We're going to do x squared minus 1, and we're going to divide that into x squared plus 1. Normally I would write a 0x there, but you can see how this will work out. You don't need it because there's not one here. X squared into x squared goes one time. This times this gives me x squared This times this is minus 1, and I subtract those 1 minus minus 1, and I get a remainder of 2. So my question now becomes 1 plus 2 over x squared minus 1. If I now consider this bit, you always remember to stick the 1 in at the minute. So consider 2 over x squared minus 1. That's difference of 2 squares, so it is reducible. So we're going to write that a over x minus 1 plus b over x plus 1. Common denominator, top and bottom of this one by x plus 1, top and bottom of this one by x minus 1, and we'll end up, I'm skipping a wee line here, and hopefully you're okay with that, a upon x plus 1 plus b upon x minus 1. If I let x equal to 1, I'm going to get 2 equals 2a. That gives me a is 1. If I let x equal to minus 1, just move up here, I'm going to get 2 equals minus 2b, and that gives me b then is minus 1. So I'm ready for my final line here. My original question was x squared plus 1 all over x squared minus 1, split into its partial fractions. Try not to forget your 1 here. My a is 1. Minus 1 all over x plus 1, and that's my answer then to question 4. Okay, on to question 5. We are getting there, doing okay. So question 5, the top line is a cubic, the bottom line is a quadratic, so we have a long division to do here, and this could be messy enough because it's a fairly substantial looking one, but let's see how we get on. So we have 2x cubed plus 10x squared plus 12x plus 1, and I'm going to multiply this out, giving me then x squared plus 5x plus 6. X squared divided into 2x cubed gives me 2x times 2x times this gives me 2x cubed. 2x times this plus 10x squared, which is handy. 2x times this plus 12x, so it's all just the same stuff. If we subtract that all, we bring it down there, that all disappears, that's 0, 0 and 0, and we bring down our 1, so we end up with a 1 there. That means I can rewrite my original question as 2x plus 1 over x plus 2 upon x plus 3. So I need to split this bit, and then it is partial fractions. So if I write and consider 1 over x plus 2 upon x plus 3, I'm going to write that as a over x plus 2 plus b over x plus 3. Let's take a look where we are. So if I get my common denominator, multiply top and bottom of this by x plus 3, top and bottom of this by x plus 2, I'm going to get 1 equals a upon x plus 3 plus b upon x plus 2. If I let x equal minus 2, this bit's going to disappear, and I'm going to get 1 equals a, that means a equals 1. If I let x equal minus 3, I'm going to get 1, that bit's just going to disappear, I get then minus b, so I get b equals minus 1, and I can just about fit this in here if I do a line here, and hopefully be able to squeeze it in. So we've got our final answer then. So my question was, split this into partial fractions, which is 2x cubed plus 10x squared plus 12x plus 1 all over x plus 2, x plus 3, and split that into partial fractions. We obviously have our 2x bit here. Plus 1 over x plus 2 minus 1 over x plus 3. And we're on to our last question. Let's see how we get on then with it. It's a tough enough one as well. Something to the power 4 here with a cubic on the bottom. So again, we need to do our long division here. So I'm going to multiply this out and we're going to get x cubed plus x squared. And I'm going to divide this into my minus x to the power 4 minus x cubed plus 2x squared minus x minus 2. So a fair bit going on there. X cubed divided into this is going to give me a minus x. If I do minus x times this, I get minus x to the power 4 as I need to, and then I get minus x cubed. If I subtract those, that becomes 0, and then I get my plus 2x squared minus x minus 2. So I can rewrite my original question as, what's it going to be? I have a minus x here. Plus 2x squared minus x minus 2 all over x squared upon x plus 1. So I have a repeated factor 1 here. And you can see this is now a cubic, this is a quadratic, so we are good to go. So it's going to be a over x plus b over x squared plus c over x plus 1. Sorry, that's not strictly true there. Sorry, I should just be considering this wee part here, so I'm going to cut this wee bit off. I hope that makes sense. Okay, apologies for that. My mistake. So doing our partial fractions then for this one. Let's make a common denominator here because this bit can be quite complicated. I need to multiply top and bottom of this one by x and x plus 1. X squared x plus 1 plus b, I just need to multiply by the x plus 1. X squared x plus 1. And then c, I need to multiply top and bottom by the x squared. X squared x plus 1. That means I can let these two things now equal each other, the two top lines. So I will get 2 x squared minus x minus 2 equals a x plus 1 plus b x plus 1 plus c x squared. If I let x equal 0, I am going to get minus 2. That's going to disappear, and I get b. So that gives me a b value of minus 2. If I let x equal minus 1, on the left hand side here, I'm just going to get a 1, because that gives me a 2, take away a 2, and then minus 1 is just a 1. If x is minus 1, this term disappears, so I just have that minus 1 squared, just give me a c, so c equals 1. If I let x equal just kind of something nice and easy, for example then x equal to 1, I am going to have, if I let x equal 1 on this side, I get minus 1. If x is 1 here, I get 2a, which is the one I'm trying to work out. If x is 1 here, I get 2 times b, so that's going to be a minus 4. Hopefully you see where that comes from. If x is 1 here, 1 times 1, it gives me 1 times a c, which is just a 1. It's just a 1 there. Rearranging that, I get a equals 1. So we're pretty much there. Let's write our final line. We are finished. My original question was, You can see this okay, can't you? Minus x to the power of 4 minus x cubed plus 2x squared minus x minus 2. That was all over x squared, x plus 1. Whenever we divide it through, remember we got a minus x out the front, so that has to come out the front. My a was a 1, so it's plus 1 over x. My b, I believe, was a minus 2, so it's minus 2 over x squared. And then my c ended up being a 1, so it's plus 1 over x plus 1.